Hey guys, and welcome to my new video. Well, this video is physics again, yeah. So we move it to chapter 5, and yes, new chapter means new problems and new issues, of course. So let's start it. Let's start with exercise 5. A car weight 1,000 kg is hooking up to a trailer of 300 kg. They're both heading the same way with the acceleration 2 for 0.15 meter per second square. Leave out the force of the air and the friction. A. Identify the forces on the car, and B. The forces on the trailer, and C. The force the trailer affects on the car, and D. The force the car on the road. Okay, so now let's start. The car mass 1 and the trailer mass 2. Mass 1 equals to 1,000 kg and mass 2 equals to 300 kilograms. And the acceleration is 2.15 meter per second square. So question A tells us to find the force of the car. F1 will equals to M1 and 2. And we have thousands with 2 or 15 here, like that. And it will be like this. Newton. And so that's what position B. The force of the trailer. A and 300 with 2.15 equals to 645 Newton. Here. And question C is a little bit tricky. It tells us to find the force of the trailer effects on the car. Well, first we have to find the force of both of this. That means F, and that just means mass 1 plus mass 2 and do it with acceleration. That will be here and there. Yeah, just like this. And yes, it would be 2,795 Newton. Well, so it tells us to find the force of the trailer effects on the car, which means we have to minus this with the force of the car, which is 2.55 here, and it equals to 645 Newton. Well, question D is tell us to find the forces a car affects on the road. We'll have to draw it out. So here we use this. This is force, and this is FGE, and this is FGX. I guess, yes, some sort of like that. So we use the aerodynamic. We use the dynamic equations. Like all of Fx will equal to here 2.15 minus 10 through 3 Newton. Well, the car is actually moving horizontal, so its force on I will probably be zero, and its force upward will equal to the gravity force, which is Gm1. G here is gravity, and we'll use 10. That means 10, and with 1,000 will equal to 10,000. Well, and we need to find the gravity force of the car on the ground, which is means you're like using like vector, Yeah, Fg will become this. Square it up like this. Square it up and plus with 10,000. Square it up, and the answers will be 1.02 and 10.4 here. Here's our answers. Okay guys, so now let's move on to exercise 15. Up there, see there are leg here and there are 4 pulleys, and which it tells us to identify the tension of these pulleys, and B tells us identify the force on the leg and identified it. Hey guys, and here. So the questions A tell us to find the tension. But the thing we need to know is that the tension at this spot here and all the way over here is the same tension in all the pulley system. So at this point of 8 kilogram, tension will equal to here, and we're just gonna draw out the free body diagram here. And its tension means to move up, and the gravity means to go down. Here is, we can see that there is no acceleration, so all the forces will become 0. And here the tension is going up, so it's positive, and it's minus with the gravity equals 0. So the tension will equal to the gravity here. The gravity is from the mass multiplied with gravity, which means 8 kilogram and with 9.8 equals to, wait a minute, 78.4 Newton. So here's our tension here. Questions B tell us to find the fractions forces on the leg. So here is the leg. The leg's over here. So we just draw out the pulleys over here, which is this 70 degree. Here the foot. So here the tension that pull out 2 sides, and the foot go with the opposite. So here F. So there are 2 kind of tension, that means T here, and this will create an angle of 70 degree. So yes, well, just need to find. So if we want to find this, we have to use T multiplied with cosines of 70 degree plus with the tension here, it means T, and minus with the force because it's go the opposite side equals 0, because there is no acceleration at all. So T multiplied cosine and plus tension equals to force, which will be which force will be about 105 Newton. Okay.